Hello everyone and welcome to my YouTube channel. So in our last lesson we have started the discussion about different methods of DNA extraction and purification. And the first method we have discussed was the phenol chloroform DNA extraction method, which is a kind of organic DNA extraction method. Okay, so we have read about the principle and the mechanism of that particular DNA extraction method, and there I have left two things. The first thing about the DNA precipitation, that how are we going to do the DNA precipitation, though we have read the steps related to that how can we precipitate the DNA, but the major thing there is why we use alcohol and salts for the precipitation of DNA. Okay, so today we are going to discuss about that. Along with that, we will be discussing about how can we measure the amount or the concentration of the DNA we have isolated. Okay, so these two things we are going to cover in today's lesson. So starting with that, DNA precipitation and quantification. So this is the topic of our study today. Moving on. Before studying about the DNA precipitation, you should know what precipitation actually means. So whenever we react a solute with a solvent and we are getting a kind of insoluble solid substance there, right? This whole process is known as precipitation. And the solid substance, that insoluble solid substance that we are getting, is the precipitate. Okay, so whenever a reaction between the solute and solvent occurs and their reaction leads to the formation of an insoluble solid substance, this process is termed as precipitation. Okay, and the solid substance formed is called the precipitate. As simple as that. Now, what is a DNA precipitation? So we have discussed that we use certain chemicals like your alcohol, like certain salts, okay, for the precipitation of DNA. But what this DNA precipitation actually means? It means that when we use that salt and the alcohol, it will react with the DNA and ultimately make that DNA insoluble in water, make it more hydrophobic in nature, because we know that water is what? It is a polar solvent, right? And only a hydrophilic substance can dissolve in water, right? So what happens when the salts and alcohol reacts with the DNA? It reduces the hydrophilic nature of the DNA and increases the hydrophobicity, because of which the DNA becomes insoluble in water. And when it becomes insoluble in water, we'll get a visible cotton thread like material, which is known as precipitate. And that is how we are extracting the DNA. That is how we are precipitating the DNA over there. Okay, so DNA precipitation is a process in which the nucleic acid is precipitated or aggregated with the help of alcohol and salts into an insoluble visible cotton thread like precipitate. So the common type of alcohol we are using for this procedure are of two types basically. One is ethanol and other is isopropanol. Though there are other alcohols present like methanol is there, so we can use that, but we don't generally use it. We will discuss why we don't use methanol in place of ethanol and isopropanol. Okay, so getting started with the mechanism of DNA precipitation, that how the DNA precipitates after using the salts and alcohol, how we get the precipitated DNA, a thread like visible substance. Okay, so alcohol is one of the essential ingredients of DNA extraction. We have already seen this. This is used for not only the precipitation but for the storing purposes and washing of the DNA. So if we want to remove the impurities, like we are using salts, so we used to remove that salt from the DNA so that the salt won't hinder with the applications, okay, like PCR. So we need to remove the salts. So for that purpose also we use alcohol. Okay, so alcohol there is not only we are using for precipitating the DNA, but for washing off the DNA, and ultimately we can store the DNA in ethanol, because ethanol or alcohol is something which is not going to react with your DNA, right? Now, alcohol along with some salts, like we can use sodium chloride and ammonium acetate, we can use those salts and we can precipitate the DNA into a visible solid form, which is a thread-like structure, we know. Okay. Now we know that the polar molecules, they dissolve in the polar solvents, and non-polar molecules dissolve in the non-polar solvents. And as the DNA is also a polar molecule, it has a negative charge on it, right? The backbone is made up of phosphate group, which is negatively charged, and that is why it is soluble in water, right? Water is what? It is also a polar solution, right? The polar solution, why we are saying it a polar solution? Because it has a partial negative charge on the oxygen and a partial positive charge on the hydrogen atom. Now this hydrogen atom, which is electrostatically free, it reacts with the negatively charged that phosphate group of the DNA. So here you can see that this water molecule here, it has a negatively charged, which is partially negatively charged oxygen atom present there, and a partially negatively charged hydrogen atom present there. Okay, so these are present in the ionic forms. So what happens? This positively charged hydrogen ion is going to react with the negatively charged phosphate ion of the DNA molecule. And when this hydrogen ion reacts with the negatively charged phosphate ion, what it will do? It will neutralize it. Okay, it will neutralize the negative nature of the DNA, and this enables this intermolecular interaction between the water and DNA molecule, makes this DNA soluble in water. Okay, now what happens when we do the precipitation procedure? What we do actually, we add some salt in this solution. So what is the purpose of the salt here? Suppose we are using sodium chloride or sodium acetate we are using. Okay. So what it will do, when it will reach into the solution, it will break into its ionic forms, right? The salt will break up into the positive ion and the negative ion. The positive sodium ion will be there and the negative acetate ions will be there. So what these positive sodium ions will do, they will interact with the negatively charged phosphate ions present on the DNA, removing the hydrogen ions, which are already been bonded with that phosphate group. Okay, so this is the basic role of the salt here. The salt will remove the positive ions of the salt, will remove the positive ions of the water, that is the hydrogen ions, and forms a bond with the negatively charged phosphate group of the DNA. This is the work of salt. Okay, now what happens? As we have discussed that this water is a polar molecule, moreover, a role of one major thing is there, that is the dielectric constant. So dielectric constant is what? It is the force of attraction. It is the amount of the force of attraction basically, which is acting on the two oppositely charged particles. Okay, so what happens if we talk about the Coulomb's law? What the Coulomb's law say, that the force of attraction between two opposite charges is inversely proportional to the dielectric constant. Okay, so if we want that this bond which is formed between the salt ion and the DNA, the negatively charged phosphate group of the DNA, it remains as it is, because this bond can break and again the water molecules will interact with the negative charge of the this DNA. But we don't want that. We want this structure, the salt, to be bounded to our DNA. That is only when the DNA will get precipitated. So for that we need one another component here, and that component is the alcohol. So what happens, the dielectric constant of the water is more than that of alcohol. Okay, the dielectric constant of water is around 80, and the dielectric constant of alcohol, if we talk about this ethanol and isopropanol, the dielectric constant of ethanol is around 24 and that of isopropanol is 20. So the whole precipitation thing is based upon this dielectric constant here. So please understand this in a better way. Okay, because if you won't understand that how this dielectric constant is working, you will not be able to understand that how this DNA is getting precipitated. Okay, so what happens, your water has a higher dielectric constant. So what it will do, when the salt, the positive ion of the salt interacts with the negative ions of the DNA, the water, because of its high dielectric constant, what it will do, it will hinder with this bond between the salt and the DNA, and it will try to break this bond. And once this bond will break, the water molecules will again interact with the DNA. Okay, and the precipitation won't take place. So if we want the precipitation to occur, we need one more component there, we need one more solvent there, and this solvent is your alcohol, right? What this alcohol will do, because alcohol, if we use ethanol or isopropanol, both of them have the lower dielectric constant. Okay, and when the lower dielectric constant will be present in the solution, what it will do, it will help this bond to be remain as it is. So here you can see, when we add the ethanol or isopropanol there, a shield is formed. The alcohol will form a shield around the DNA and the salt bond. And because of this, the water molecules will not able to bind with the DNA. And so this bond will remain as it is, and ultimately the precipitation of the DNA could occur. So this is why we require the alcohol. Okay, so since water has a high dielectric constant, it hinders in the sodium and this phosphate binding. Hence it is necessary to use the alcohol for DNA precipitation, as your alcohol has the lower dielectric constant as compared to water. So it protects the sodium and phosphate complex from water by forming a shield over it, over that complex, and the force of attraction between the sodium ions and the phosphate ions increases after the addition of alcohol. So this is how the alcohol is going to preserve this complex of salt and DNA and will lead it to precipitation. Okay, so this is the basic mechanism behind the precipitation. I hope you understand it. If you don't understand it, I would say you should recall this video once more to understand, and still if you are getting some problem, you can write me in the comment box. Okay, now there are certain questions. The first question is, why other alcohols like methanol are not used in DNA precipitation? So I have told you that the major thing we require here for the precipitation is the dielectric constant, the lower dielectric constant. Okay, the whole precipitation thing is based on dielectric constant. So if the solvent has lower dielectric constant, the force of attraction between the two oppositely charged molecules will be higher. Okay, but if the dielectric constant of the solvent is high, the force of attraction between the two oppositely charged molecules will be low. So at that moment, the salt will not be able to form bonds with the DNA, and ultimately precipitation won't occur. So if we compare the dielectric constant of ethanol, isopropanol and methanol, we will see that methanol has a higher dielectric constant than that of your ethanol and isopropanol. So the dielectric constant of methanol here is around 33, which is higher than that of ethanol and isopropanol. So this is not preferable for the precipitation of DNA. Though you can do that, but the yield will not be that suitable. Okay, then second thing is methanol is quite toxic in nature. That is why we don't generally use methanol. Moreover, the boiling point is very low, and the boiling point of this ethanol and isopropanol is higher than that of methanol. So these two alcohols are more safe for the use in DNA precipitation. Okay, then next is, in our last lesson we have discussed that when we use salts for the precipitation of DNA, we generally don't go for isopropanol. Though if we use chilled isopropanol, it will lead to a better precipitation. But when we use salts, we generally don't prefer this isopropanol. Why? Because isopropanol, what it does, it precipitates the salt in a higher quantity. So ultimately the DNA will remain with the impurities, the salts. We don't require this salt. Okay, so generally when we use salt, we avoid using isopropanol along with that, and especially chilled isopropanol. We don't use chilled isopropanol, and we never do the this freezing step over there, because freezing and chilling will lead to more and more salts to be precipitated along with the DNA. So we don't want that. Okay, so isopropanol, it leads to the precipitation of the salt too, and hence the DNA still remains with the impurities. Secondly, while using isopropanol, freezing of the sample is not preferred, and also chilling method is not applied at this. It will lead to the salt precipitation along with the DNA. So we don't want this. Further, why we use chilled ethanol? I have told you that ethanol can be used for precipitation, further for washing of the DNA, and for storing of the DNA. So we wash the DNA with chilled alcohol or chilled ethanol basically, so that all the salts can be removed from the DNA. So we give 2-3 washing of ethanol to remove these salts and other impurities from the DNA. Okay. Now why we use chilled ethanol? Because flocculation is very important. If flocculation occurs, we'll get a higher yield of precipitation. So for obtaining the high yield of precipitate, the process of flocculation is important. Hence, for chilling is necessary. That is why we use chilled ethanol. So chilled ethanol is providing you with the higher precipitation of the DNA, higher yielded precipitate. Okay. Next we come to the end of this lesson, that is the measurement of the DNA concentration. How are we going to measure that what amount of DNA is present there, what we have isolated? So basically this measurement of DNA concentration is done with the help of UV absorbance spectrophotometer, ultraviolet absorbance spectrophotometer. Okay, so DNA concentration or the DNA concentration can be measured with the help of UV absorbance spectrophotometer. Now what happens? The amount of the UV radiation absorbed by the solution of the DNA, it is directly proportional to the amount of DNA in the sample. If you know the principle of spectrophotometer, you will understand this line very well, that the amount of UV radiation absorbed by the solution, that will be directly proportional to the amount of DNA present in that sample. Okay, usually if you are getting the absorbance of 1, generally we measure the absorbance at around 260 nanometer, and if you are getting the absorbance of 1, it means that in a sample you have around 50 mg of double stranded DNA per ml. Okay, so absorbance the one absorbance unit will describe you that there is around 50 milligram of double stranded DNA present in the sample per ml of the sample. So with the help of UV spectrophotometer, you can detect the amount of DNA present in the 1 ml of your sample. Then ultraviolet absorbance can also be used to check the purity of the DNA. How much is your DNA pure? Whether it is pure enough to be used for further applications or not. So how we are going to detect that? It is with the help of a ratio. So with a pure sample of DNA, you can compare it with a pure sample of DNA, the ratio of the absorbance at 260 and 280 nanometers, and it should be around 1.8. Okay, if the absorbance is or if the ratio of the absorbance at 260 and 280 nanometer is less than 1.8, then your DNA contains impurities, and that impurities could be your protein or because of the phenol. So you should understand this thing, that whenever you measure the DNA, the amount of DNA, the first thing you do is take the absorbances at 260 nanometers. Okay, and the absorbance of 1 will corresponds to the 50 mg of your double stranded DNA per ml of the sample. Okay, now if you want to know the purity of your sample, what you will do, you will check the ratio of the absorbance at 260 and 280 nanometers, and if the absorbance is less than 1.8, it means your DNA is still impure. It contains protein, it contains phenol or any other kind of impurity. Okay, so that's it for today's lesson. I hope you really understand each and everything that I've told you here. Okay, my comment box is open to everybody who is getting problem in understanding things. So you can ask your questions there. And if for further queries, you can also mail me at manishamalhotra92@gmail.com.